Good day to all of you. Today we shall discuss on question number 6A from model question paper set 1 for the subject digital design and computer organization, the subject code being BCS 302. The question is demonstrate the branching operations using a loop to add n numbers with block diagram. This carries 8 marks. Solution. So according to this question, the program we have to consider, which is written in assembly language, and that program adds n numbers which are stored in memory. And for n numbers, the memory locations reserved are num1, num2, num3, num4 till num_n. So if 10 numbers, num10. So there are 10 memory locations reserved, and in which 10 numbers are stored one by one. So num1 is the memory location which holds first number. Num2 is the second memory location which holds second number, and so on till num10 is the 10th memory location which holds 10th number. So apart from these 10 memory locations, one more memory location called SUM, that is reserved, in which the sum of all the numbers is going to be stored. Then one more memory location where how many numbers are to be added, that is n. If 10 numbers are to be added, so in that memory location called n, 10 is stored. If 5 numbers, 5 is stored. Okay. So other than these memory locations, we have another part of memory where instructions are stored, that is where program is stored. So with this prior knowledge, we shall answer this. So consider the task of adding a list of n numbers, num1, num2, num_n. So till num_n indicate symbolically the addresses of memory locations containing n numbers. So this diagram we have to consider, which shows memory locations. So num1 memory location, num2, num3, and so on till num_n. These memory locations hold n numbers. Then this is another memory location whose name is capital letter N. In this 5, 10, that is number of numbers which we are going to add in the program, that is stored. Then this is another memory location called SUM, where we are going to store the result, that is the addition of all n numbers. And memory locations are continued here. So this part of memory locations, if you consider, where program is stored. Okay. So here what is the program? Move n, r1. So from n memory location where we have stored number 10, if we want to add 10 numbers, so that content of n memory location, that is number 10, is copied into register r1. Then clear r0. Register r0 of processor is cleared to store the sum in the computation. Then here in this block of memory, looping instructions are written. So what is looping instruction here? So it fetches first number, adds to r0, then it determines the address of next number, that is num2. So it adds to r0 and keeps the result in r0. It decides the address of next number, that is num3, adds to r0. So on till num_n. So each time when number is added, say num1 is added, decrement r1, because in r1 10 we had stored. Here when num1 is added, r1 is decremented, means it is made 9, means 1 is already added. So one number is already added, the remaining number of numbers are 9. Branch if greater than 0, means r1 is greater than 0, means not at all the numbers are added. So to loop this label, it is here. This will determine the address of next number, adds it to r2, Then decrement R1 means this time it is made 8 because it is greater than 0, indicating that still 8 numbers are to be added. So shifts the control back to loop label here. This determines the address of next number, adds to R0, again decrements R1. This time it is 7. So still branch greater than 0 means R1 is 7. It has not yet become 0. That means not all the numbers are added. Hence shift the control back to loop. So determine the address of next, add to R0, decrementing R1. These are repeated 10 times. Loop from here to here, whatever instructions are there. Determine the address of next number, add to R0, decrement R1. If R1 has not yet become 0, shift the control back to loop. This is repeated 10 times if n is 10. So after 10 time means all the 10 numbers are added and the result is in R0 and R1 has become 0, indicating that all the numbers have been added 0. Branch greater than 0 is false now. It will not shift the control back to loop label. So branch has become 0 here, means R1 has become 0, means all the numbers addition is over. Then instead of control shifting back to loop, it comes out of the loop and it goes to next instruction, that is move R0, sum. Means whatever result, that is addition of n numbers was there in R0, that is copied to some memory location. This is how using loop instruction 10 numbers are or n numbers are added, the result is kept in R0 and finally that is moved to sum. Before starting the loop instructions, R0 is cleared to store the sum and R1 is storing the number n and R1 is being used as the counter. After complete execution of the program, due to last instruction, see whatever result was there in R0, that is copied to some memory location, means in some named memory location we'll have the answer. So this is what is the demonstration of branching operations using a loop to add n numbers with block diagram. So this diagram of memory it is. From here to here program, that is instructions one by one, they are stored. So here memory is continued and this is the memory location for holding the sum. This is the memory location to hold n, that is how many numbers are to be added. Here individual memory locations used to keep the numbers number 1, 2 till number n, and the names of memory locations are NUM1, NUM2 and so on till NUMN, that is num1, num2 till num-n. Symbolically they represent the addresses of memory locations where numbers are stored. So this block diagram we have to draw. The explanation we can write as follows. Consider the task of adding a list of n numbers. Num1, num2 till num-n indicate symbolically the addresses of memory locations containing the n numbers. Register R1 stores count n, that is 5 or 10, that is how many numbers we want to add. Register R0 is clear to store the sum. Every time next number is added to R0 in this loop block. After adding one number, R1 is reduced by 1. If R1 is not 0, go to loop to find and add next number. After all n numbers are added, the sum value from R0 is copied to memory sum, SUM. So this is the memory to store the result sum, and this is the memory to store count n. If 10 numbers, 10. If 5 numbers, 5. So these are n memory locations storing n numbers. Here branch greater than 0 is a conditional branch statement. After adding one number, counter R1 is decremented. If it is greater than 0, control jumps to label loop, where finding and adding next number instructions are stored. Otherwise, control goes to next statement, that is move or not comma sum, to store the result of addition of all n numbers into sum memory. Okay, that is the solution of question number 6a, asked for 8 marks. So what was the question? Demonstrate the branching operations using a loop to add n numbers with a block diagram. This is for 8 marks. I hope you understood. Next we shall solve question number 6b. The question is, the registers R1 and R2 has decimal values 1200 and 4600. Calculate the effective address of memory operand in each of the following instructions when they are executed in sequence. So this carries 7 marks. So question number 6a carried 8 marks and 6b is carrying 7 marks. So what is given in the question? In R1 and R2 registers of processor, 1200 and 4600 are stored respectively. Means in register R1 1200 is there, in register R2 4600 is there. So what we have to do? We have to calculate the effective address of the memory operand when the following instructions are executed sequentially. Means we should go on solving the question. We should go on considering the given instructions one by one sequentially, means one after the other. So the first instruction is load 20 in bracket R1 comma R5. So load instruction copies the content of memory location into register. So here this is source part, this is destination part. So from memory it is brought and it is stored in R5. That is what is the function of load instruction. So which memory location? So that address what we find, that is called as effective address. Effective address of the operand. Here 20 in bracket R1 means this is indexed addressing mode. So in bracket means R1 is holding some memory location address. So what they have given R1 equal to? So given is R1 equal to 1200. So 1200 memory location address is there. That is added to 20. So 1220 it becomes. So from 1220 memory location, in that memory location what is stored? That is copied to R5. Means memory location whose address is 1220, that memory location content is copied to R5. So the operand address is 1220. That is effective address. So effective address is equal to this 20 plus R1. R1 given is 1200. So 20 plus 1200 equal to 1220. Hence effective address is 1220. Means from which memory location the operand is copied to R5. That is effective address and that is here 1220. So after this one instruction, next move hash 3000 comma R5. So this is the source and this is destination. Move means it copies the content of this to this destination register here. So the content of this means here hash means it is a number. Which number? 3000. So which operand is to be copied? Okay, this is immediate addressing mode. So the operand is given immediately in the instruction itself. So operand that is 3000, that is given immediately in the instruction. This belongs to immediate addressing mode. Hence the operand is the value itself here, that is 3000. Okay. So the effective address means it is in the instruction only. Then what is the operand here? That is 3000. So operand is equal to 3000. Here the operand was brought from memory location whose address is 1220. The effective address is 1220. So after second instruction, the third instruction executed is store R5, 30 in bracket R1, R2. So this is source, this is destination. Store means from processor register it is copied to memory. So then which memory here? R1 plus R2 plus 30. So R1 given is 1200. So 1200 plus 4600 because R2 given is 4600. Both are added. After adding, this must be added. So that will be effective address. 30 plus 1200 plus 4600 equal to 5830. This is the address of memory location in which R5 content is going to be stored. Okay, that is what is store operation. Store operation copies the content from processor register to memory location. Hence the effective address here it is 5830. Then fourth instruction is add this minus sign, that is decrement sign in bracket R2, R5. This instruction belongs to auto decrement addressing mode. So add does addition operation. So this content plus this content. So one operand is in R5, another operand here bracket R2 means it is the address. R2 holds the address. What is R2 content given? 4600. So this is pre-decrement. Auto decrement addressing mode, in that it is pre-decrement. So since R2 holds 4600, first it is decremented by one word. So 4600 is decremented by one word, means if word size, if it is decremented by one word, if each represents one word address, decremented by 1. So 4600 minus 1, that is 4599. Assuming is a each word address here. Okay. If these are byte addresses, if word length is 4 bytes, then 4600 will have to decrement by 4. Then 4596 would be the operand address. So that would be effective address. So with this comment we'll have to answer. I am assuming that all 4600 are word addresses. So it is decremented by 1. So 4599 will be effective address. So from that memory location, the content is added to R5 and the result is kept back in R5. This only is the destination. This plus this is done because it is add operation and result is kept back in R5 only. That is processor register R5 only. Okay. If all 4600 are byte addresses and if one word length is 32-bit 4 bytes, then this should be decremented by 4. Pre-decrement means by one word size decrement. Then 4600 minus 4. 4 bytes is equal to one word. So then this would be 4596. So these comments we'll have to write and then write the answer here. Then fifth instruction is subtract R1 plus R5. In bracket R1 means this is address. Subtract means this minus this, result is kept in R5. This means bracket is there, that is memory address. R1 given is 1200. So this plus indicates that is post increment. So this instruction belongs to post increment kind of addressing mode. So first it must subtract this R1 pointed memory content from this R5 content and result has to be stored in R5. Here R1 value given is 1200. So from 1200 memory location, whatever content is there, R5 is subtracted and result is kept in R5. Then R1 is incremented. Anyway, the operand is brought from 1200 memory location only. hence effective address is 1200. After subtract operation, R1 will be incremented by one word address. Okay. So that completes the solution of question number 6b, which is asked for 7 marks. So this question is based on different addressing modes. 5 instructions are given. They are executed sequentially, one after the other, and in that sequence only we have to go on calculating the operand address. That will be effective address. Okay. So I hope you understood. So next we shall solve question number 6c. Explain single bus structure. This is asked for 5 marks. Question number 6a was for 8 marks, B asked for 7 marks, and C is asked for 5 marks. So question number 6 ABC totally for 20 marks. Okay. So here we have to explain single bus structure. So this diagram is to be drawn. That is figure, the title being single bus structure. What this diagram shows? The different parts of a computer which are connected through connecting lines, that is called as bus. So because single set of bus is there, that is called as single bus structure. At any time, any two devices can do communication over the bus. So a group of lines that serves as a connecting path for several devices in a computer system, that is called as bus. So figure above shows single bus structure. So this is the bus and different parts of the computer system are input, output, memory and processor. Input is used to give the data and instruction to processor. Output, when processor gives the result, it interprets in the user understanding manner. Memory is used to store data and instructions. Processor means it executes arithmetic and logical operations on the given data. So whatever data and instructions are passed between the different parts here, they are passed through bus, that is connecting lines. Processor internally has two parts, ALU and CU, arithmetic logic unit and control unit. Control unit controls and coordinates the activities of different parts. Arithmetic and logic unit performs actual arithmetic or logical operations which are specified in the instructions given to processor by the user. So figure above shows the bus that is connecting different parts of computer, that is input, output, memory and processor. There is single bus, that is single set of lines. This single set of lines or this single bus may have data, address and control lines. Means in that single bus or set of lines, 3 different kind of lines will be there. So the lines which carry data, they are called as data lines. The lines which carry address bits of the memory, they are called as address lines. And the lines which carry the commands, the control bits from the processor, they are called as control lines. All these data, address and control lines form single bus. Because bus is single, that is a single set of data, address and control lines in that, the bus can be used for only one transfer at a time. Only 2 units can actively use the bus at any given time. The bus control lines are used to arbitrate multiple requests for use of the bus. Means whenever any 2 devices are communicating over the bus, till that is over, the third unit cannot use this. Okay. So it has to request. So to shift the control between different units for transfer of data between the 2 units, that process is called as arbitration. The bus control lines are used to arbitrate multiple requests for use of the bus. The main advantage of single bus structure is its low cost and its flexibility for adding new peripherals. means new input output devices or any other external device, that is called as peripheral. Externally, that which is connected to computer system, that is called as peripheral. If any new peripheral has to be added, then it is very flexible because there is only single bus and its cost is also low. What is the advantage? The main advantage of single bus structure is its low cost and its flexibility for adding new peripherals. If multiple bus structure is used, performance is improved but cost is more. Why cost is more? Multiple lines are required, multiple set of lines. Here only one set of lines, one set of data, address and control lines are used, that is single bus structure. In multiple bus structure means multiple set of lines will be used, hence it is costly. But in single bus structure, till communication between the two units is over, the other units cannot use the bus. They have to wait. So speed of execution is reduced. But that is not the case in multiple bus structure. The speed is increased because the other bus is available for communication between the other unit. It need not wait till the communication between the two units is over. The third unit can use the second bus. Okay, hence the speed of execution is increased, that is performance is improved, but cost of multiple bus structure is more. So that completes the solution of question 6C, explain single bus structure, which is asked for 5 marks. That completes the discussion of question 6ABC from model question paper set 1 of subject digital design and computer organization, the subject code being BCS 302. I hope you understood. Thank you.